One thing that I do want to make sure we hit on here is to talk about scalability, because this is obviously such a hot topic in the entire crypto community. It's sort of a Johnson measuring contest when it comes down to it. How fast is your blockchain? How many transactions per second can you boot? But Hydra is a very, very interesting innovation that Cardano has brought out. So you tell us a little about what Hydra is and how that's working to scale Cardano.
Yeah, so first off, you have to talk about what is this thing you're scaling around. So the basic unit of interaction in these systems is generally a transaction, and then not all transactions are created equally. So a Bitcoin transaction is fundamentally different from the things that happen on Ethereum or Cardano. So general transactions have 5 properties. So usually they have an asset that you care about, something of value. So that's a token or the underlying currency of Bitcoin, an ADA, something like that. You're moving something. Then you have entities involved. And then you say, well, what types of transactions are allowed? One-to-one, one-to-many, many-to-one, many-to-many. There's different messaging patterns that you have there. So, for example, you could do 1,000 transactions one-to-one or one transaction to 1,000 people, right? So it just depends on how you bunch and bundle these things. Then you have metadata. So metadata is saying, well, what's the story of the transaction? So what does the system talk about? It's going to keep a timestamp. Maybe it's going to have a bunch of context about geography. Where did this transaction happen? And that can be very important, by the way. Like if it was drawing $100 from an ATM, it's very different when you're doing it next to a restaurant versus doing it next to a brothel. Probably have same type of transaction, same type of value, but you're imagining, there's probably a different context of what you're doing with that. So it'd be really unfortunate if that was preserved forever. So there's a metadata component. Then there's contractual components. So you're thinking to yourself, well, what level of complexity, the spending policy that's in here, how many contingencies are here? Like, can I only send you money if I prove that I am a lawful, legitimate actor? So maybe there's a compliance layer like KYC and AML, or maybe you're only accepting money from certain geographies. Like I only take money from America, but not from North Korea or something like that. So there can be all kinds of exotic spending policy that's embedded there. And then they all live in a regulatory regime. So you have to think, well, how do we handle that? Do we want to automate it or is it off chain? And then you have identities, like who are these people? So it's not just the pattern of how many you're sending it to. Is it Lark to Charles? Is it Lark to Microsoft? These types of things you think about. So your system has to make opinions about all the things on chain that are going to be done for you. And if you do a lot of that on chain, that transaction that you're doing is a lot more sophisticated, takes a lot more time to validate, it's a lot larger in terms of its space than if you're only doing one of those things on chain like Bitcoin. It doesn't have support for multi-asset. So the only thing you do is a push transaction between addresses with specific validation logic. So all that other stuff, the named actors, the metadata, you have to kind of extract it somehow outside of the system. So that's the first thing. Is you have to put the goalposts down of what is a transaction. Then the next step is, well, how many of these things, once you've set the goalposts down, can you do per second? Okay, so then we say this much TPS or that much TPS. And then there's a question of value. So do you want the same settlement system for all transactions? So do you want the $5 billion transfer of value to be on the same settlement rails as the microtransaction that you do to tip a video that's less than a penny? Do they have the same economic priority? Do they share the same state space in the UTXO or the account space or something like that? So the point of Hydra is to take a slight opinion on this and say, okay, Cardano is a very powerful system. So it's significantly more stuff can go into the transaction than in Bitcoin. So we created a new model for this called the extended UTXO model. It allows us to have spending policies and multi-asset and smart contracts and all these things. And DSLs could even bring in regulatory dimensions. And embedding Prism in means we can put identity native on chain. So there's a lot of cool stuff there. And that's a very sophisticated transaction. And the base ledger can perform very high speed for these things because Ouroboros is a very efficient protocol. So you can potentially have hundreds of these things going on every second. But then when you start stratifying these transactions, you're going to notice that big pools of them are low value transactions. Big pools of them are occurring frequently, but collectively are only talking about maybe 5%, 10% of the total value of a ledger. So a lot of turnaround, but they're just bloat. So it makes more sense to batch those and put those into a different layer of the system and allow then for those things to enjoy acceleration. So you can do a lot more of them. The fees go down. They get instant finality instead of having to wait for probabilistic finality. And that's kind of the concept of Lightning. So what we did is we just took the ideas of Lightning and we said, can we have native smart contract support for this and build it so that you can have as many channels as you want, and they can all communicate with each other, route with each other. And every time you add it, you get linear scaling. So what that means is you get X more TPS per second capacity, instead of saying that it goes up and up and up and then it reaches an asymptote and just stays at a constant performance. One head, two heads, three heads, N heads, the system just keeps scaling. So potentially you could grow to the capacity of millions of transactions per second, long-term, years from now, decades from now, if you wanted to. And the great part about stake pools and delegation and all things of Ouroboros is you have a very natural set of people to run this infrastructure. So as we start growing, you put these Hydra heads on top of stake pools, and then they have now 2 settlement channels. And so you can either settle on the main network or you can settle on the layer 2 network, and it's completely dependent upon your requirements. Is it the value very high or low? Do you care about the settlement speed? Do you want fast settlement speed or slow settlement speed? These types of things. And basically they just work together and it's a seamless user experience. It's all there. So Hydra took a long time to develop because it was one of our truly interdisciplinary papers. First off, we did it with our consensus team, but then we also did it with our programming language team, because it wasn't good enough just to say you can put a transaction into the channel and it can do some things and then it comes out. We said you can put smart contracts with real state into these systems. They run and they do things. So the PL guys had to figure out how to do that and guarantee that things would be preserved and there wouldn't be rollbacks or other such things. So it was really a complicated effort, but we ended up doing it. It was one of the greatest collaborations we had, with Manuel Chakravartis leading the PL effort, combined with Agalos and his team leading the consensus effort. But the end result is we have a beautiful base protocol. And we have a prototype team led by Rob Cohen, one of our product managers. And they're kind of exploring, when we need this, how would we roll this out? How would we create a canonical design, almost like the Bolt spec for Lightning? And then basically at some point Cardano can embrace it. And this becomes one dimension of scaling that we can achieve that's completely complementary to what Ethereum is doing, which is ledger-based scaling, which is a significantly harder thing. And it's not clear to me if they gain anything more by doing it in the way that these markets work right now. And it allows us to get a lot of that bloat that these systems tend to accumulate off-chain into different systems. The other really exciting thing about Hydra is you can make it interoperable with Lightning, and then you can actually start talking about cross-chain compatibility through that. So we talk interoperability. And so you say, well, how do you move Bitcoin to Ether or Bitcoin to Cardano and back and forth? So when you could put a DEX in there, you could actually exchange in there. You can do all kinds of cool things once you have these layer 2 networks running. And basically just allows you now to start talking to other systems and talking in a way that there seems to be a standards-driven approach pushing through. Whether you love Lightning or hate it, it is an approach that Bitcoin is very aggressively pursuing. And it is an approach that is interoperable with Ethereum. So through this type of a system, once we get it all wired together, it'll be very easy for Cardano to talk to Ethereum and Bitcoin through those channels. So you can do more than just microtransactions and fast finality and high frequency stuff. You also will be able to do, all of a sudden, be able to communicate with other systems. So that's kind of the vision of Hydra, and it's a longer arc thing. It's not necessary right now. We're not even using 2-3% of the total capacity of what Ouroboros can provide. Most of these next generation proof of stake protocols are sufficiently performant that you're not saturating them yet. But it's a very easy way of adding scalability into the system without a hard fork, without a soft fork. It's just there. Plutus alone, extended UTX alone is enough to do it. We designed it with the PL guys to guarantee that. And we already have a set of people who are ready to go, the stake pool operators. And it's just an additional business line where they can make more profit. And because we built it with our accounting model, it's not just for ADA. It'll actually be for any user-issued asset on Cardano. When our multi-asset standard rolls out, you can take your token that you've issued on Cardano and run it through these channels. So suddenly you get fast finality and microtransactions and all of these other things basically added in when that's available. So it's going to be fun to do, and it probably will end up being done through a competitive process. So we might end up implementing a reference version, but then we'd love to see other developers in the ecosystem build their own variants, and they would collaborate around a specification. And then the stake pool operators and other people can decide to run their own channels wherever they want to. In fact, anybody can run a Hydra channel. You just have to put a pledge and basically lock some coins to secure that channel. So yeah, that's been one of our funnest pieces of research. It was kind of like the icing on the cake, or the the cookies you get to dip in the milk. Had to a lot of work to get to a point where you could do something like that. But then this beautiful, elegant thing just kind of fell out, and it sits on top of everything, and it doesn't require mass disruption. If you look at the F2, not only are they changing a consensus protocol, they're going from a single shard space to a multi-shard space, and that requires traumatic disruption. You have to think of all these things. How are you going to manage time? How are you going to manage the manufacturing random numbers? You're going to have availability problems in the ledger, all this stuff that you would not get in a single shard environment that becomes exponentially more difficult to work your way around. And so you're putting a lot of implementation, execution, and ecosystem risk, so probably slower to market. Whereas this thing, whenever it's needed, you just put on top, and then suddenly we could technically process millions of transactions if we really wanted to. There was a path to that that is very graceful, and it no way prevents us from pursuing the same approach that Ethereum is pursuing. And if we wanted to, we could do that, and we would organically grow to that. But it's probably not necessary. The base ledger probably could get up to about 1,000 transactions per second with these enhanced transactions we're talking about. There's a lot of questions of, is that even desirable? Like, there's a lot of network capacity issues there, and then you'd have to think of different ways to synchronize. So state space would have to be better managed, probably with snarks or things like that. So there's a lot of work to do if you want to get to that load. And that's for everybody. It's not just for us. And then there's philosophical questions like, do you wish to preserve inclusive accountability or not? You never hear this in the TPS conversation, but it's the hidden trade-off that everybody has to think about. So what is inclusive accountability? Basically, it's everybody checks each other's homework. This is what Satoshi promised when he created Bitcoin. He said, hey, here's Bitcoin, exclusively accountable. I can check it, you can check it. Nobody's special, meaning your check is just as good as my check. And we all do it, and that's what keeps the system secure. So every full node can regenerate the system, and every full node knows that the history they're looking at is valid according to the rules of the system. The problem is when you go to high-performance systems, the systems just have too much going on for 99.99999% of users to be able to run a full node and validate it. So could you imagine what are the consequences of a 1,000 transaction per second system long term? Even if these transactions are modestly sized, you could imagine a blockchain that's in the petabytes or exabytes. Mm-hmm. Who can preserve that? No one. And so then there's too much network traffic as well. So who can keep up with the heartbeat of the network? Very few actors. So what means you centralize around a small group of people that preserve the whole system. So anytime you talk about scalability and how do we achieve high throughput, it's in the same breath you have to talk about, well, what are our principles? Do we wish to preserve inclusive accountability? Because the technology you need to do that is much more complicated and much more experimental than just the technology you need to achieve scale. So what we chose to do is say, let's keep it as simple as we can and have a beautiful single sharded high performance environment that can have that property of inclusive accountability for at least the next few years comfortably. And then let's add a system on top that slows down the rate of growth, but also gives us high performance. And that gives us the ability for the next 5-10 years to have a very comfortable growth window for performance. And then if the community chooses to invest in this technology, we could look at things like recursive snarks and other things to basically bring inclusive accountability in as a permanent feature, regardless of how big the system gets. We also need to do a lot of network innovation to make that happen.